Hi, welcome to a video podcast on phase. Can be a little bit of a tricky subject, this one, but we'll start off by just getting straight to what you want to know. So we're going to draw a progressive wave, and this just shows the position of the medium at one time. The wave is travelling in this direction, and each point is moving up and down with equal amplitude. Each point of the medium moves with the same frequency, but it doesn't all move at the same time. So if we take 2 points one wavelength apart, like these two peaks, we can imagine if we were watching this wave, we would see these 2 points moving in phase. And we say that if 2 points are one wavelength apart, then they have a phase difference of 2 pi. Now obviously if 2 points were 2 wavelengths apart, they would still be in phase, and we can describe in phase as 2 pi or 4 pi. Going right round the circle again, as I'll explain later, has no meaning. If we now consider 2 points that are half a wavelength apart, then we can see they would be moving completely out of phase with each other. And points that are half a wavelength apart have a phase difference of pi radians. I'll stop doing it on the diagram now and you can just follow the logic. Points that are a quarter of a wavelength apart are pi by 2 radians phase difference. It's unlikely that you'll need any more than that, but it's just a matter of applying a ratio and realising that the root of the ratio is lambda and 2 pi. If you're asked the phase difference between 2 points which are 1.5 wavelengths apart, then you can simply subtract 1 wavelength and the answer would be pi radians phase difference. Now if you don't like explanations, you can probably leave it there, but just to try and explain something about where that 2 pi is coming from. If we imagine a spinning disc, if we imagine a point on that disc and we watch it as it completes a complete circle, if we were to plot a graph of the height of that point from that line as it moves through a complete circle, we would see this, we would see a cos function. And the reason for that is if I quickly draw in that point at this arbitrary point here, if we keep that distance there as a constant, that's actually the amplitude of the motion. There's an angle here, and the height is a cos theta, so not surprisingly, we've drawn a cos graph. If we consider this point here, how would its graph look as the disk continues to rotate through a complete cycle? Well, what we would see is a graph of something that's completely out of phase, and the angle between these two things on the discs is pi radian. So that's one way of visualising what these phase angles mean. If you can imagine an imaginary disc rotating, the angle between the 2 points that we're following the height of is the phase angle. And of course there's another explanation which is simply to say that if the top graph is a graph of cos theta, the bottom one is a graph of cos theta plus pi, and this is the phase angle. It's simply how much one graph has been moved relative to the other graph along the x-axis. Okay, hope that helps. Thank you very much.